Hi, my name is Patrick Koch. Welcome to my session about the migration of a containerized legacy application to the cloud. Don't give up just because it's legacy. So this indicates probably some painful experiences, right? But as I can already reveal, those are the valuable ones. I'm glad that you would like to get insights about our cloud migration journey. Therefore, let's go. Today's agenda starts with an introduction. So who am I? Who is my employer? What about our legacy software application? And after that, I will continue with three main parts. So the first one is about the time before the cloud. After that, I will talk about our first challenge. So it's about implementing a proof of concept in the cloud. And the next main part is about the next logical step, as we ensured that the proof of concept fulfilled its objective. And finally, I will finish the presentation with a conclusion, respectively with an outlook. Right, so let's jump in the introduction part. I'm an employee of AVL List. AVL was founded in 1948. We have more than 11,000 employees worldwide. Our headquarters is in Graz, and in Graz we have approximately 4,000 employees. We have 45 affiliates worldwide, and AVL is the world's largest independent company for development, simulation, and testing in the automotive industry. Currently, we are facing new challenges with regards to electrification, autonomous driving, emissions, vehicle, and data intelligence. But I'm quite sure you probably know AVL. Therefore, I will move to the next slide, which is about a short introduction of myself. So my name is Patrick Koch. I live in Graz and I work as a DevOps engineer for AVL since 2014. Therefore, I really love to have topics related to cloud, Kubernetes, container, and CI/CD. If you would like to get in touch with me, feel free to write me an mail or to reach me via Twitter or LinkedIn. And of course, I would be happy if you visit my blog. Right, but what's probably more interesting for you would be to get more details about our legacy software application, and especially why I call it a legacy software application. So the real name is AVL Concerto. AVL Concerto is a data processing platform used in the automotive industry. The development started more than 25 years ago as a Windows application. Just to get a feeling, we have about 23,000 users and approximately 600 customers. But as you can see in the timeline, starting with 2014, there were huge changes made. So Concerto evolved to a platform product within the company. We added a Python scripting support. We added a REST interface. An automation framework was implemented. And almost 3 years ago, I think, we created our very first container. So it's a Windows container at which we deploy Concerto. And we also tried to deploy it on a real Kubernetes productive system. After that, we invested some time with regards to web components and latest developments concerning making Concerto ready for Linux. And what's the probably most interesting part, 1 year ago, we started a proof of concept with Microsoft to get a use case from the customer in the cloud. And that joint venture was also the trigger for our cloud transformation story. And the whole content is now part of this presentation. So that about the introduction section. Now let's jump into the time before the cloud. So what did we do before we dealt with cloud topics, Kubernetes, and container? I would like to provide you a feeling for our use cases. And in case of Concerto, it starts with that guy here. So what you can see here is an engine testbed, which is capable of testing engines. So it's about diesel, natural gas, dual fuel. And it's for engines up to 660 kilowatt. So imagine that you walk into the room and you try to apply different use cases. So you try to get measurements out from the speed, the acceleration, and you can't see it, but in this room there are also specific devices which can simulate specific temperatures. So in the end, you get a bunch of data out from your test cases. And after that, it's Concerto's task to do the post-processing of those data. So the customer would like to create diagrams, reports, and so on. How does that look like? So that's Concerto. Imagine you now get the data out from the engine in a file. So you got data related to emissions, to the speed, etc. And the work of a validation engineer would be, for instance, to start Concerto, trigger a specific script which is generating the final report, which should provide specific results for the customer about the engine. So that's our common use case, which we support for almost three centuries. And this use case has now to be transformed in the cloud, containerized using Kubernetes. So sounds tricky. But before I go into the detail, how did we do that? I would like to explain to you why do we do that. So because in general, it's the use case is working, the customer is happy. So why do we have to jump into the cloud to do provisioning to get the use case in Azure, for instance, using state-of-the-art Kubernetes services and deploying workloads? In general, it's quite easy. So here on the left, we have again our common use case, including the engine testbed. But due to the rise of electric cars, we have now following situation. What you can see here on the right is a factory including so-called battery cell test chambers. So each of these chamber contains several batteries. A battery consists of several modules, and each module contains several battery cells. And due to the amount of data which needs to be processed, we can compare the data flow or the data from one battery cell with the output of one test case with the engine testbed. And so you might now understand that for the future use case of our already current use case, including electric cars, we need to rapidly scale up Concerto or Concerto instances, because otherwise it would take much too long to get to the results. And therefore we ask us the question, how can we increase the degree of automation there? Because a validation engineer wouldn't do that in a manual way. And on the other side, we knew we need some other technologies to scale up our Concerto instances. Therefore, a Kubernetes service would fit. But in addition, as some kind of requirement, we need, of course, to containerize Concerto. So this would affect the containerization and Kubernetes. But why should we do that in the cloud? In general, we already got at that time some general requests from customer whether Concerto is capable of running in the cloud. So the requests increased, and we just asked the customer, why would you like to do that in the cloud? And they told us, yeah, they simply don't want to manage the infrastructure on-premise anymore. And therefore, it was also clear to us that if we realize this new use case, including the testing of the single battery cells, that the customer wouldn't be happy if we provision a Kubernetes cluster at his on-premise cluster. So he wouldn't be happy with that. Therefore, it was clear to us, okay, we need to scale up and we have to do it in the cloud. But as mentioned, we're dealing with a legacy software application. So we are faced with a kind of mission impossible, because it's about legacy software application, which is not intended to run in the cloud, even not intended to run at a container. But we already had time pressure. We got the requests. We know that the rise of the electric car will probably continue. Therefore, we have to be ready for the new business, for the new use case. Therefore, it was necessary to find a strategy to migrate to the cloud now. And how did we do that? At first, let's just consider some aspects of the customer to get a better feeling according to their requirements. So the customer would like to use their really customized workflows running on their single office PCs. So they're used to that. They would like to, they don't want to change that. But as I've told you before, so due to the increase of amount of data, due to the rise of the electric cars and the testing of the single battery cells, we are confronted with this new situation. So we really have to scale the existing workflows and the existing apps which the customer use to be ready for the new business. But also we have to be prepared that the customer would like to migrate to the cloud. And now the big question is, how do we start? And for that, we had two possibilities. The first one would be do a refactoring, a rebuild. The second one, lift and shift. So putting Concerto in a container and trying to deploy that at the Kubernetes service, for instance. Due to the time pressure and the lack of resources with regard to the manpower, it was clear to us we need to use the lift and shift approach. So that was clear to us, and there, with that mindset, we started our proof of concept in the cloud. According to the architecture or the single components, this is what you can see at the next slide. So that would be our goal. So we have several Concerto instances. So that's the orange icon, which can be scaled up for doing the processing of existing customer apps. And the final result would be a report, similar according to that one, which you have seen before. The requests are triggered from a so-called message broker, which is a Linux component. So each request results to the deployment of a workflow, which runs Concerto, which is doing a processing, and finally you get a result, and that's a report, for instance, a PDF. And where do we get the input data from? So there we also had two possibilities. We needed to cover two different ways. The first one would be to get the data from a database inside the cloud. And the second one, as you can see in the left, to get the data from outside therefore the VPN tunnel. It's a rather simple reason for that. We are sure that not each customer will be happy if we tell him that the data which is needed for doing the processing has to be in the cloud because of some very discrete data. Right, so we knew the plan, we knew what we would like to achieve. Now it was time to implement the stuff. According to the architecture, I'm glad that Microsoft already provides some so-called architecture solution ideas, and that picture fits perfectly to our requirements. So we have our existing application, which is Concerto, containerized, of course. We push it to an Azure container registry, and by triggering dedicated kubectl commands, we are able to deploy the workloads, so the running Concerto, at an Azure Kubernetes service. So that's the goal. But how did we were very successful for the first time for doing when we started the implementation? So for sure not. So we failed several times. So the thing is, we really started from scratch. So we provisioned the AKS in a manual way by using the Azure portal, and we tried to configure the corresponding deployment rules for the workload. And so the simple goal was just to run Concerto containerized at the AKS, and we struggled very often. And I would like to reveal our pain points. So the first one, what you can see here, container registry is not properly attached to the Kubernetes cluster. So this means that the Kubernetes cluster doesn't have the permission to pull the container image from the container registry for deploying the workloads. Then you get, for instance, that state, so error image pull, and yeah, we had it, and we really need to investigate there. The second pain point: be sure to use sufficient and the right deployment rules of your workload. So in our case, Concerto is a Windows application, therefore we hadn't time to refactor it, to put it on a Linux container. Therefore, we used a Windows container, and when we tried it the first time, or some further times, to deploy it at the AKS, which includes, of course, also Windows nodes, then we also didn't succeed, because we recognize that if you don't have that statement in your YAML code of the workload, then the Windows workload tries to get run at a Linux node. Can't work, of course. And the third one, maybe some detail to that. So if you start up Concerto, you need some license features from a license server, which is FlexLM in our case. And FlexLM has some specific ports which you have to enable. And we recognized just, I think, 1 day or 2 days later that we need to take care of a specific dynamic port range, which you can see here on the very right side. So those are the 3 pain points which let us struggle a lot. But from my point of view, when I look back, maybe we started too complex, as we didn't have the know-how at the beginning how to run a container in the cloud anyway. We maybe shouldn't have started with doing that at an AKS. But we found a solution. We used an alternative approach. We thought, let's try a different approach and let's create an Azure container instance. Why should we do that? What's the benefit of that when you would like to start? So when you create a new container instance, you get that view where you can put the name of the container instance in. But the real benefit, especially when you start, is that you can choose your container registry. So if you created a container registry in the Azure subscription, including your images, so you can choose it here in the drop-down menu. And so therefore, the Azure container instance manages the connection to your image. So you don't have to take care of the first issue. And also the second issue will be tackled by creating the container instance, because also the container instance manages also for you whether it's about Linux or Windows. So with implementing an Azure container instance, we could get rid of the first two pain points. So we just could focus on the last one. But for that, we simply restarted the container instance, we redeployed it, and we simply tried to enable port by port and to debug, and we recognized a very strange or very high port, which has to be enabled according to the logs. So we recognized this dynamic port range, and finally we could get Concerto run containerized in Azure for the very first time, just as container instance, but it ran. And this, on the one hand, motivated us, and therefore we had time to just tackle the very the second pain points. So to properly attach the container registry at the Kubernetes cluster and to find the proper deployment rules. And finally, we succeeded, and we could get Concerto run at the Azure Kubernetes cluster, and we were happy. And for that, as the use case worked, at least to a specific degree, we thought, okay, that's good, but how can we provision the whole infrastructure, for instance, at customer side? So we needed a virtual machine for the license server, for instance, a resource group, of course, the Azure Kubernetes service, the Azure container registry, etc., a storage. How can we provision it? And we thought it would be great to find also an automated way for that. And there we thought that Terraform would be a good idea. So the goal was now to do an automated provisioning of the Kubernetes service, the container registry, and all further resources which we need. And for that, Terraform works great. So you are writing some so-called Terraform configuration files, and in one configuration file, you can define all the related resources which you need. And in addition, we also integrated Azure DevOps pipelines, which do the provisioning in an automated way by simply triggering an agent pipeline job. And on the next slide, I would like to show you how does it look like in real. So it's a short video. Here on the right, you can see the Azure portal, on the left, our Azure DevOps server. And now we are going to trigger a pipeline which is applying a Terraform init and a Terraform apply. Therefore, in this demo, this provisions a new Kubernetes cluster in our Azure subscription. It's generally really easy. We also created our own build agent for that. So just take a Linux-based container, for instance, and simply install Terraform on it. It's also done very quickly. So as you can see, the pipeline is now running on the left, and here on the right, we can see that a new Kubernetes service with the name strong terpon -AKS was provisioned. Of course, this video is now trimmed, but I think including our Windows nodes, it just takes, I think, 8 to 10 minutes to be ready. And that's rather fast from my point of view. Right, so we also found a way to provision it for the customer. But what I would like to show to you is how does now our use case, so creating a report out of input data, look like in the Azure cloud by using the AKS and by the deployment of workloads. Just a short switch back to the architecture. So we now provisioned with Terraform the Azure Container Registry, including our container image and the Azure Kubernetes service and all the additional resources. And in the next video, which I would like to show to you, is that you can see how we trigger our Concerto workloads by using the kube CTL CLI commands and how the report is generated. So it's about that AKS. Let's switch to the next slide. So here on the right, you can see again an Azure Kubernetes service. On the left, it's about a file share, which will be the proper destination for the reports. So now we are going to apply our workloads using kube CTL at the Azure Kubernetes cluster. So the first workload is now running. Let's also trigger a second one just to demonstrate that we can run the workloads in parallel, of course. And each workload is going to do a different processing. So in the end, we will get 2 different reports. That should be the result for the customer. So now both are running. Let's click on it to get to the Kubernetes pod. As you can see, it's in a running state. Therefore, on the left at the file share, the first directory appears, which will include the final report. Let's also check the second workload. You can see the pod is also, again, in a running state. So this implies that a second directory at the share gets created. And after a few minutes, but just to be honest, that's now just about a demonstration. It's a rather easy calculation. But in the end, we will get our reports. So let's check the first one. So that would be an example report for the customer. Let's switch back to the Kubernetes service. And as we can see, also the second workload is done. So Concerto also did a second processing. Let's also download the second PDF. And as you can see, it's about a different report. All right, so we transformed our common use case to the cloud using Kubernetes, using workloads. And yeah, it works, but are we now happy? So cloud check, Windows containers check. Of course, according to our long-term plan, we are not finished, of course. So what do we expect for the future? We would like to get rid of our Windows containers and try to run the components which we need for the new use case at a Linux container. Therefore, let's again consider our 2 possibilities, refactoring or rebuild, respectively lift and shift. So the new approach, according to a long term, will be now the refactoring, respectively the rebuild. What does it mean in context of Concerto? On the left, you can see some major components of Concerto. So we have a native UI, a managed UI, a managed subsystem, a native data managed subsystem, COM component, .NET. And we are planning to take that stuff which we need for the new use case, so the native data management subsystem, and make it ready for Linux. So we are going to deploy in future the necessary stuff at a Linux container. And as you can see, also Python will be important. And this comes from the customer. Here on the next slide, I would like to explain to you the future use case in more detail. In the video, you've seen how we can apply our workloads at the Azure Kubernetes service. But of course, the customer won't do that. He won't use kubectl for doing that. So the future of the data validation engineer and the data analytics could be that the customer writes his own Python script, and from the Python script, we need to derive our workloads, as you can see. So the arrow goes to the AKS, and there we derive the new Linux-based workloads, including the proper components of Concerto. But there's something new here. So that's prefect and task. So prefect is a, let's name it, workflow automation tool. Prefect allows you to write tasks within a Python script and to containerize it as a flow. I will give you an example on the next slide. So how does it look like? So imagine that would be an example of a customer or of a data validation engineer. So the customer is going, for instance, to write his own Python script. Inside the Python script, inside Python, he defines his tasks, for instance, the sample task, and this task, or multiple of them, can be containerized within a so-called prefect flow. So if you run that prefect flow, the tasks are getting executed at a Kubernetes service in that case. So here in line 10, you can see it's a flow named my Concerto flow, and it refers to a YAML file in which we define the rules for our workload. And if you trigger that, you will get a prefect job, which includes our Concerto container in the end. So how does that look like in real? I would like to demonstrate that to you in this video. So here on the left, we are going to trigger a prefect run, and this prefect flow, which will result, implies a Kubernetes job. So now we type, if you can't read it, prefect run. We have to reference the name of the flow, which is my Concerto flow. We just also refer to the label of an agent. And after that, we trigger it. And then you can see that on the right, which shows an Azure Kubernetes service again, that we get a Kubernetes job. So that triggers our processing of Concerto. That will be the future use case. As you can see, a job named prefect job -6 la la la, and we get it running. Let's check the Kubernetes pod, and inside the pod we have our Concerto container, which is doing the calculation. And in the end, we are again getting a dedicated report, based on the processing. Right. So that already concludes our future use case. So it was a rather intensive journey, just to ramp it up, to give you an overview. It all started in 2019 with the containerization of Concerto for the very first time. So the deployment of Concerto at a Windows container. In the following year, so in 2020, we invested time to deploy the container at a real Kubernetes service. So we used Ranger, as we had it in our company for internal development. And we also invested much time in the CI/CD pipelines for our containerized Concerto, which is, to mention it again, running at a Windows container. In 2021, we started with our proof of concept with Microsoft, so to get an existing use case from the customer in the cloud in Azure, using the Azure Kubernetes service, the container registry, and all the other further resources which we need. In this year, we already started with the refactoring of Concerto with regard to make it ready for Linux. And we also started with the Python integration, and we did our first experiments with Prefect as a workflow automation tool. And in the next year, let's see, but we are quite sure that we have to learn more about Prefect, also with Task, to make the use case more efficient. And this already brings me to my last slide, so the key learnings of our journey, let's say. So we simply figured out that when you handle such complex topics, really start as small as possible. So MVP first. In general, it's important, I think it's probably familiar to you, to stay curious. So what's the current technology which you could use for your use case? What's very important in our case, so as you can see, we had to migrate to the cloud. We had to use Kubernetes. We had to use the containerized version of Concerto, not because we thought it's a good idea to be at the latest technology, but it's of course a good idea. But the main driver was the customer. So it's about an architecture-driven business. The architecture is driven by business, of course. With regards to the cloud, use infrastructure as code. When we started the proof of concept, we didn't have that much time, so as we also had to take care about our releases. So, for instance, in a week, we just had, for instance, 1 day for our proof of concept. So therefore, we need to provision all the stuff which we need and to destroy it again. And therefore, infrastructure as code, for instance, or with Terraform or with Azure Biceps is great. So when you need it, provision it, and we don't need it, simply destroy it, and there are no costs allocated. And in addition, also try to get out of your comfort zone. So always try to learn new things, but I think it's a really common advice. And in general, in addition, use existing tools. So for instance, don't try to write your scaling tool or your automation tool on your own. Use existing well-established software, as for instance, the Azure Kubernetes service, if you would like to scale your workloads. So now I'm already at the end of our cloud migration journey. I hope you enjoyed it. I hope you got some benefit out of it. And sorry, there's another one. And I'm open. Feel free to ask questions, and I'm curious about that. And therefore, I would like to thank you for your attention.